Is time travel possible? No wastage of time, let's get started. Time travel, moving between two different points in time, has been a popular topic for science fiction for decades. It would be amazing if one could travel in time. In many franchises, we have seen many humans messing with time. The reality is much more complicated. Not all scientists believe that time travel is possible. Some even say that an attempt would be death causing. First, let's understand what is time. While most people like you and me think of time as a constant, physicist Albert Einstein showed that time is an illusion. It is relative. It can vary for different observers depending on your speed through space. To Einstein, time is the fourth dimension. Space is described as a three-dimensional arena which provides a traveler with coordinates such as length, width, and height, showing location. Time provides another coordinate, direction, although conventionally it only moves forward. Einstein's theory of special relativity says that time slows down or speeds up depending on how fast you move relative to something else. Approaching the speed of light, a person inside a spaceship would age much slower than his twin at home. Also, under Einstein's theory of general relativity, gravity can bend time. Picture a four-dimensional fabric called space-time. When anything that has mass sits on that piece of fabric, it causes a dimple or a bending of space-time. The bending of space-time causes objects to move on a curved path, and that curvature of space is what we know as gravity. Time will pass slow for someone traveling at high speed in vacuum relative to someone standing still. Let's imagine you left on space flight today. On that flight, you flew around outer space at nearly speed of light for around 3 years according to your clock. However, as I said earlier, the clock on Earth moves much faster. In fact, more than 60 years would have passed on Earth. You would only be a few years older, but everyone on Earth would be much older when compared to you. Understood? Okay. If not, then rewind and listen it again and again till you get it. This effect is called time dilation. Let's take another example of time dilation using gravity. It is called gravitational time dilation. You are on a planet with very high gravitation when compared to Earth. You spend 10 to 20 minutes there, but it would be 10 to 20 hours in Earth. Let's assume the Earth and that high gravitational planet on space-time fabric. Earth bends the space-time fabric less when compared to the high gravitational planet. So, time runs slower in high gravitation planet relative to Earth. This is called gravitational time dilation. Time dilation clearly explains to us that astronauts are time travelers, as they return to Earth very slightly younger than their identical twins who remain on the planet. And people who can step to other planets can too travel in time. General relativity also provides scenarios that could allow travelers to go back in time. The equations, however, might be difficult to physically achieve. One possibility could be to go faster than light, which travels at 186,282 miles per second in vacuum. Einstein's equations, though, show that an object at the speed of light would have both infinite mass and a length of 0. This appears to be physically impossible, although some scientists have extended his equations and said it might be done. A linked possibility for time travel would be to create wormholes between points in space-time. While Einstein's equations provide for wormholes, they would collapse very quickly and would only be suitable for very small particles. Also, scientists have not actually observed these wormholes yet. Also, the technology needed to create a wormhole is far beyond anything we have today. So, you have to travel faster than light speed to time travel. But there are yet other ways to time travel. Let's explain one of them. Another possibility would be to move a ship rapidly around a black hole or to artificially create that condition with a huge rotating structure. Imagine they circle the black hole for 5 of their years. 10 years would pass elsewhere. When they got home, everyone on Earth would have aged 5 years more than they had. But how to deal with gravity of black hole? Seems very risky, right? So, can we time travel? To build time machines, we need a form of matter which violates physics laws with so-called negative energy density. Such exotic matter has bizarre properties, including moving in the opposite direction of normal matter when pushed. Such matter could theoretically exist, but if it really did, it might be present only in quantities too small for the construction of a time machine. But we can time travel without that exotic matter. It is called a warp drive. Ever watch Star Trek? No? Okay. Warp drive in Star Trek works by destroying matter in the form of deuterium and antimatter in a fusion reaction mediated by dilithium crystals. This produces the enormous power required to warp space-time and drive the ship faster than light. So everything seems possible for time travel. Then what's the problem? Here enter the paradoxes. Number 1. Grandfather paradox. You go back in time and finish your grandfather before your father is born, and you and your father don't exist. So if you don't exist, how will you finish your grandfather? Number 2. Predestination paradox. Okay, imagine this whole thing. Your friend Alex is coming to meet you at a park and he dies in a car accident. A year later, you time travel into the past and decide to save Alex. To reach the accident spot, you drive very fast and met with an accident. The person in the other car dies and the person's name is Alex. Number 3. Bootstrap paradox. One fine day, your doorbell rings and you open the door. No one's out there. But there's a book titled How to Make a Time Machine on your doorstep. You manage to make a time machine with the help of the book after 20 years. You travel back in time to the day you got the book, place the book at your doorstep and run away to your timeline. So what's the origin of the book? It was never created. It was you who gave the book to yourself. These paradoxes make us think that time travel is impossible, and these are only some of them. Famous scientist Sir Stephen Hawking too believes that. But these paradoxes can be solved with the help of one single term: parallel universe. Every time you go back in time, you enter a parallel universe where everything is identical to the previous one.
But movies have shown something else.
Yes, let's come to that topic. I will not use much of your time. By the way, you can skip here. Many movies use their own methods to time travel. Let's know some of them. Time travel by moving through higher dimensions. In Interstellar, there are tesseracts available in which astronauts can travel because the vessel represents time as a dimension of space, traveling faster than light. In Superman, the movie, Superman flies faster than light to go back in time and rescue Lois Lane before she is killed. Time travel through quantum realm. In the movie Avengers Endgame, Avengers time travel by using quantum realm. Ant-Man shrinks to the size of subatomic particles and enters into quantum realm, where time runs differently. He spends only 5 hours in quantum realm to travel 5 years in the normal world.
Time travel!
But we can't shrink to that size. Maybe using future technology we can. So, is time travel possible? Time travel does not appear possible. Possible if the humans would survive it with the physics that we use today. The field is constantly changing. Advances in quantum theories could perhaps provide some understanding of how to overcome time travel paradoxes. In my opinion, for humanity to time travel, we have to make a spaceship that moves faster than speed of light, or we ourselves have to move faster than light, or someone should give us the technology to how to do it, and he or she must be from the future. For then the answer to the question, Can we time travel? Is no.